Okay, this chapter is really going to focus on polynomial equations and functions, but let's start with a note about quadratic functions. We learned earlier there's two ways you can write quadratic functions. One is f of x equals ax squared plus bx plus c, and then the other form is the standard form that makes it easy to find the vertex. Remember that the graph of a quadratic function opens upward if a is positive, and it opens downward if a is negative. So, and also remember the vertex is this lowest point when it opens upward, and it's this highest point when it opens downward. Now the standard form allows you to find the vertex. So for instance, if you have y equals minus 2 times x minus 5 quantity squared plus 3, well, we know the vertex is the point 5, 3, and the axis is the line x equal 5. And we know that this one opens downward since the a is negative. The a here is negative 2. Now this one, the vertex would be the point negative 2, negative 4, and the axis would be the line x equal negative 2. And since a equal 1, that's a positive number, is understood to be a 1 right there, the parabola opens upward. We also talked about before that if the parabola is given to you in this form, you can find the vertex. The h value of the vertex, or the x value of the vertex, can be found by the formula minus b over 2a, and then you can find the k value, which is actually the y value of the vertex, by plugging that number back into the function. So if you wanted to find the vertex of, say, this function here, well, a is negative 4, b is 16, c is negative 2, so do minus b over 2a, so that'd be minus 16 over 2 times negative 4. Well, that would be minus 16 over negative 8, which is plus 2, which this needs to be corrected, huh? Okay, let's try this again now that I've got it corrected. Alright, so as I said, it should be negative 16 over negative 8, which is 2. And then when you plug in negative 2 here, positive 2 here into the function, you're going to get negative 4 times 2 squared plus 16 times 2 minus 2. Well, that's going to be negative 4 times 4, which is negative 16. This is going to be 32, so negative 16 plus 32 gives me 16, and 16 minus 2 is 14. So your vertex is actually the point positive 2 for x and 14 for the y value. So that's your vertex. So as I said, the vertex is 2, 14. So as you can tell, I try to correct these as I'm working through them. It's much easier to see the errors as you're working through them. Okay, so when you're graphing quadratic functions, the things you need to try to look for is determine whether it opens upward or downward by looking at a, and then find the vertex and the axis of symmetry. And sometimes you can find x-intercepts, but I will tell you that when you're looking for x-intercepts, if you get imaginary numbers, then it's just a parabola that doesn't cross the x-axis. Now, it may give you numbers that are irrational numbers, which you might have to use a calculator to estimate. And then you can find the y-intercept, in other words, f of 0. And if you need to, you can plot additional points. All right, let's look at one that's written in the standard form. Here I know that it opens downwards since a is negative 2. I know that 3, 8 is the vertex, and the axis of symmetry is the line x equal 3. If I try to solve for x-intercepts, I get set it equal to 0. I can move the 8 over, and that becomes minus 2 times x minus 3 squared is negative 8. Then divide both sides by negative 2 here, and so when you divide both sides by negative 2 goes into negative 8, gives me plus 4. And then using the square root theorem, x minus 3 must equal plus or minus the square root of 4, so plus or minus 2. So x minus 3 equals plus or minus 2, so x must equal 3 plus or minus 2. So 3 plus 2 is 5, and 3 minus 2 is 1. So that means the x-intercepts are the points 1, 0, and 5, 0. And then if you let x be 0, you can get the y-intercept. The y-intercept here, let's see, it's going to be negative 2 times 9, so that's negative 18, and then plus 8, so that's going to be negative 10. And then if you need to find other points, you can, but I'm just going to go with what we know here. We know the vertex is here at the point 3, 8. And notice I drew kind of, this axis is really like an imaginary line. It's not part of the graph. So you draw that dotted line down through there, and that splits the parabola in half. And then actually by knowing the x-intercepts are 1, 0, and 5, 0, I can probably just draw from here down through here, and then from here down through here, and get a pretty good graph of the parabola. But if you wanted to, you could plug in values, other values of x, like here 2 and 4, and see that the y values are 6, and get another couple of points. So just depends on how accurate you need your parabola to be. Okay, now if it's given in this form, 2x squared minus 8x, well, first of all, I know it opens upward. I know it opens upward because a is positive, 2 is positive. And then using the vertex formula, let's see if I did it right this time. Minus b would be minus negative 8. Well, that would just be 8 over 2a, so that'd be over 2 times 2. So that's 8 over 2. I'm sorry, 8 over 2 times 2, which is 4. So 8 over 4 is 2. Okay, now I got to plug 2 back into this. So 2 times 4 is 8. And then 8 minus, what would minus 8 times 2 would be minus 16. So I'd have 8 minus 16, which is negative 8. And so that gives me the point 2, negative 8 with an axis of x equal 2. And then if you set this equal to 0, you can solve it by factoring. You can get your x-intercepts by just factoring 2x out. And you see that the solutions are 0 or 4. So it crosses the x-axis at 0, 0, and 4, 0. And when x is 0, you get 0, 0. So 0, 0 is an x-intercept and a y-intercept. And if you want another point, you could try 1, since 1 is just to the left of the vertex, then whatever you get for 1 is going to be the same number you're going to get just to the right of the vertex, which this should actually say 3, not 2. So I know if 1 unit to the left of the vertex, I'm going to get negative 6. Then I know 1 unit to the right of the vertex, which is 3. That's an ugly 3, isn't it? 1 unit to the right of the vertex, I'm going to get negative 6 as well. So anyway, you can plot those points and graph the parabola yourself. Okay, now what I want to do now is just to remind you that if a is 0, a is greater than 0, then that means that the graph opens upward and therefore has a minimum at the k value. That's just the y value of the vertex. And then if a is, this should say less than 0, if a is less than 0, the graph has a maximum of k at the x value. Okay, so now if I want to find the maximum or minimum of these, well, first of all, I already did both of these. So this one I know the graph opens which way? Downward. So since a is less than 0, since less than 0, this must have a maximum, and the maximum's got to be the y value of the vertex. Remember, this had a vertex of 3, 8, so the y value was 8 at x equals 3. And then this one, it opens upward, and so it's got to have a minimum. And its minimum is going to be the y value of the vertex, which we found up here to be negative 8 at x equals 2. So anyway, that's how you find the maximum and minimum of a quadratic function, is just find the y value of the vertex. Now, a couple more examples I wanted to go over here. Here's an example of an underwater projectile that's following a particular path. And notice here the path is minus 3x squared plus 6x plus 13, where x is horizontal distance and f of x is the depth. So it says find the maximum depth. So basically, to find the maximum depth, we just need to find the vertex. So if I do minus b over 2a, that's going to be minus 6 over 2 times negative 3, so it's minus 6 over minus 6, which is 1. So the horizontal distance is 1 mile, but to get the depth, I have to plug that back into the function. And so when I plug that back into the function, I get minus 3 plus 6 plus 13. So that's going to be minus 3 plus 6 plus 13. That's going to be 16 miles of depth. Okay. Now, the domain of a quadratic function is generally all real numbers. Obviously, the domain here, you might change the domain here to, instead of being all real numbers, start with 0, because in this problem, normally the domain would be all real numbers for a quadratic function, but since we're talking horizontal distance here, I'm assuming the projectile is not going to start at a negative value, so probably that would be better to say 0 to infinity. And then the range of this projectile would actually be negative infinity. Now, technically, I don't know what the depth of the ocean is or whatever the water is, but normally we would say the range is negative infinity up to the y value of the vertex when it opens down like that. All right, let's look at this example, and then the next one you can look at on your own. It says when a football is kicked, the nearest defensive player is 6 feet from impact with the kicker's foot. The height of the ball, f of x in feet, can be given by this function, where x is the ball's distance in feet from the point of impact of the kicker's foot. What's the maximum height of the ball, and how far from the point of impact does this occur? Well, to find from impact, we just need the x value of the vertex. So I'm going to find the x value of the vertex. So the x value of the vertex would be minus 1.18 over 2 times negative 0.01, which is about 59 feet. So the maximum height would be about 59 feet after it's kicked. So plug 59 into this function, and I actually got 36.81 feet roughly. And then the next one says how high must the nearest defensive player who is 6 feet from the kicker's foot on impact reach to block the kick? Well, basically what I need is the height of the ball 6 foot from the kicker. So find the height at 6 feet. So find the height at 6 feet, and we get 8.7 feet. So the defensive player must reach a height of about 8.7 feet, because that's about the height of the ball when it's kicked. So he's got to be able to reach that height in order to block the kick. Okay, so this other application, you can freeze the video and work it if you want to, but it says if you have 100 feet of fencing to surround a rectangular region, what dimensions will give you the maximum area? Well, you'll notice that we want to maximize area, and you can easily determine that the length plus width must be 50. Then you can solve for length in terms of width, and then you can plug it back into this area formula, and you end up getting 50 minus w times w. And then that's a quadratic function, and you can use the vertex formula to find the width that gives you the maximum of that, which is 25, and then you can go plug back into the length formula to get the length, which is 25 as well. So it turns out the dimensions just need to be a square, and the maximum area would be 625 square feet. So what's interesting about that is you can make that rectangular dimension a lot of different sizes, but only the dimension 25 by 25 gives you the maximum area.